All right, so we should be recording as of this moment. Yesterday, I started talking about connective tissues, and now I'm going to continue doing that today. I am going to do a quick review and add some things to the general characteristics of connective tissues. That's where we left off. I'm not going to completely go through the same exact connective tissues that I've already done because we have to get on with that. So step one with this is I'm pulling up my whiteboard, okay, so that we can start, so that I can draw some pictures and actually explain things to you in not only in verbal format, but also in writing. So let me do that. I'll pull up a whiteboard, give myself some room. And this is the topic that you don't have to write this down. And this part that I'm starting with is review from yesterday. And I wrote, what makes a connective tissue a connective tissue? Really quick review. There's 4 main tissue types in the human body. I keep reiterating this, so obviously I'm going to expect you to know this for the next quiz. They are epithelial, connective, muscular, and nervous. We've done epithelial. We're currently doing connective. And connective tissues are the most abundant tissue type in the human body. And what makes a connective tissue is the components that there are living cells. We did this yesterday. I'm just doing this as a repeat. And a non-living matrix. And I'm not going to redo this whole thing. I'm going to quickly say, what is a non-living matrix? That is a ground substance, that's supposed to be a U, combined with fibers. So the non-living part of connective tissue is made up of fibers and a ground substance. Fibers can be 3 types. It can be collagen fibers, which are really strong, known for their strength. Elastic fibers, which are thin and known for their recoil, their elasticity, or reticular fibers, which are kind of a combination of the first 2. A ground substance can either be, can vary in its consistency, its constituency. It can vary from being a fluid, from one extreme like blood, or something very hard and dense like bone. I am going to talk more today about the living cells that we find in connective tissue. We did some of it yesterday. I told you what a blast is. That is an immature cell, and it's usually the blast form, that immature cell that secretes the fibers and or the ground substance. So just remember, blast means immature cell that secretes something, either fibers or ground substance. And then the suffix cyte, C-Y-T-E, means a mature cell. So for example, a fibroblast would secrete fibers. A fibrocyte is a mature living cell that doesn't secrete things anymore. So I'm not going to write all that business down again. We did that yesterday. I'm just going to write other cells, other living cells in connective tissue. That means other than the blasts and cytes. There are other types of cells in connective tissue. I'm just going to list, I'll try to do a fairly short list. We've got fat cells, which are also known as adipocytes. They're very common in connective tissue. There are white blood cells found migrating in and out of connective tissues. There is something, you might not have heard this before, there are something called mast cells, M-A-S-T. And mast cells they release histamines and initiate an inflammatory process. So in parentheses after mast cells, these are cell types that release. I'm sure you've heard the word histamine before. I'll tell you what that is. A histamine is a chemical, and it's a chemical that causes vasodilation. It causes our vessels to expand. So when you're having typically an allergic reaction, or if you have allergies to something, some cells in your body are releasing histamines, causing you to feel stuffed up or stuffy. That's from vasodilation and increased, I'm just going to write increased inflammation. So these are just some other cell types that we find in connective tissue other than things like site cells and blast cells, fat cells, white blood cells, mast cells, and finally, the last one I'm going to write on the list. These are good terms for you to start learning now because they're going to come back up throughout the semester in A&P, and in A&P too if you take that. Macrophages, these are sort of a non-specific immune cell that just engulf foreign cells. So after macrophages, they undergo a process called phagocytosis. They phagocytize other cells. That means to engulf or eat. So for example, if a foreign microorganism gets into your body somehow, some way, macrophages in your body go after that thing, whatever it is, and try to destroy it. They try to engulf it and destroy it. So these are just other cells that we find in connective tissue. Fat cells, white blood cells, mast cells, and macrophages. All right, so I'm going to repeat this verbally, but I'm not going to write all of this out. What we did yesterday was we started looking at specific connective tissues that I have listed on the outline that's posted on our website. And what we accomplished, this is just quick review, what we accomplished was all of the connective tissue proper classification, which included areolar, adipose, reticular, dense regular, dense irregular, and elastic. And I'm going to tell you right now, this will help you since you're attending this meeting. What I focus on when I ask questions on the quiz about connective tissue is I'm going to ask you some questions about these general characteristics that we have gone over. And then the questions that I ask about specific connective tissues are maybe one or two questions about one question about their general characteristic, but more what I focus on when I ask questions on quiz day is, for example, areolar, adipose, and reticular. I would like you to try to remember the locations and functions that I gave you. And I only gave you one or two for each. So for example, I'm just pulling one out of the hat. When I'm making up a question for students on a quiz about, say, reticular connective tissue, I'll think, oh, I want them to know that the function of that is it provides an internal framework for soft organs. And B, I want them to know where do we find that tissue in soft organs like lymph nodes and the spleen. And it's the same with all of these tissues. So I get it. Your head is going to be sort of overwhelmed. My God, there's so many tissues that I have to know. Well, we finished all of the epithelials, so I won't ask you about those again. So when I ask you about all of these crazy connective tissues, that's why I gave you this outline so that you can just jot down location and function next to each one. And that will help you condense all of this information, and you won't have to think that I need to know every word in the textbook about all of these tissues. So we finished areolar, adipose, reticular, dense regular, dense irregular, elastic. We also finished the cartilages, hyaline cartilage, elastic cartilage, and fibrocartilage. So today I'm going to start with bone. Oh, sorry, we did do compact bone. I remember now, we did compact bone and spongy bone. So I'm going to go on to the last connective tissue, which is connective tissue classification, which is fluid. So I'm going to erase this whiteboard and call up a new one. And just write, this is our last major classification of connective, and it's called fluid. I'm going to write fluid CT for fluid connective tissues. And there's just two of them, which is good. The first one is blood. So it is imperative that you understand that blood is a connective tissue. And what makes blood a connective tissue? I'm just going to write this. This will help you. The living cells of this connective tissue are red blood cells and white blood cells. I'm just going to put WBCs, and something called platelets. Technically, red blood cells and platelets are not true cells, but they are living elements. Anyway, red blood cells, white blood cells, and platelets make up the living component of blood. The non-living matrix in blood, you know what it is, you just didn't know it was a non-living matrix, is blood plasma. It's the fluid part. So the non-living matrix is blood plasma. And plasma is just the fluid portion of blood. These cells are suspended in that fluid. All right. So these would be living cells. These cells, this is a unique situation in connective tissue. It's pretty much the only connective tissue that the cells don't actively always secrete fibers. And it's so complicated that I'm not going to require you to know this for the quiz. When you study blood in A&P2, you do it in depth. You'll learn more in detail how the fiber part of blood works, and it only works when we're bleeding to stop the bleeding. So anyway, what I'm writing is what I want you to know, and its location is easy. It's just the cardiovascular system. So in all of our vessels and in our heart is where we find blood. You know that. That one's fairly easy and quick to cover. The second one is called lymph. It's a fluid connective tissue. Lymph is just the fluid that we find in the lymphatic system. Our lymphatic system is a similar system to the vascular system, our blood vessels, only there are lymph vessels that contain fluid. So this fluid is considered a connective tissue. The living cells, so I'm just going to put cells that we find in lymph fluid are those macrophages that I described earlier, and different types of white blood cells, mostly, specifically T cells and B cells. So these are examples of living cells that we find in this lymphatic fluid. All right, so I'm going to go on now. I'm going to erase this board. If you want to screenshot it, go for it. Or if you would just want to watch the recording that I'm doing after this is finished, you can do it that way. So let's pull up a new whiteboard. And just to remind you, this is just review. Tissue types. We can check this box. Epithelial. We're done, and you've been quizzed on it. Connective. We're done, but you haven't been quizzed on this yet. So the last two tissue types, and I'm not going to go into detail with these, are muscular and nervous. Like I said in a previous lecture, we're going to do the muscular system later in A&P1, and we're going to do the nervous system. That's supposed to be a U. We're going to do the nervous system later in A&P1, but I am just going to mention them while we talk about tissues because they are two of the four main tissue types. So let's do muscular. And there are three types of muscular tissue. And they're listed on your outline. Number one, skeletal muscle. This tissue type is what you and I think of when we hear the word muscle. This is the stuff that is, so I'm going to give you some characteristics. It's attached to bones. That's actually its location. This is all the things that are attached to bones that produce what we call skeletal movement, this type of muscle is voluntarily controlled. So we have conscious control over these muscle contractions. If you want to raise your arm, you raise your arm. You want to take a step forward with your leg, you can do it. You can control those actions with your brain consciously. The cells, the muscle cells, which are called fibers, are very long and cylindrical or cylinder shaped. And the last thing I'm going to say about the skeletal muscle, is the cells and the tissue is striated. That means when we look at this tissue under a microscope, it has a striped appearance. Sorry, I am going to say one more thing. The cells also, each individual cells have many nuclei in them. There's more than one nucleus per cell. So I'm going to write cells are multinucleate. You'll learn how a muscle works, how these skeletal muscles generate a contraction, how they use energy, how they store energy, yada, 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 all when we do the muscular system. This business that I've just written is what I'm going to expect you to know for the next quiz, okay? So I'm running out of space. Rather than erase this board, I'll just call up a new board, so in case I want to go back to the old one, but nevertheless. So that was skeletal muscle. I'm going to write number 2. Smooth muscle is the second type of muscular tissue. Smooth muscle is found, located in organ walls and vessel walls. So in our blood vessels, in the walls of our blood vessels, we find this smooth muscle. In the walls of our organs, specifically digestive organs mostly, we also find smooth muscle. So your stomach, for example, is lined with smooth muscle, just like your arteries and veins are lined with smooth muscle. So that's the location. This type of muscle is not voluntarily controlled. We don't have conscious control over this muscle. So I can't think to myself in my head, oh, I want my stomach to start churning and digesting, or I want my vessels to constrict or dilate. That's involuntarily controlled. The cells are not striated. They do not have stripes when we look at them under a microscope. You'll understand the significance of that when we study muscle tissue in detail. And the cells only have one nucleus per cell. So that tells you a little bit about smooth muscle cells. Not a lot, but a little bit. You don't need to know a lot for this next quiz. You need to know these basic differences. Third type of muscle is cardiac muscle. Just like the name implies, cardiac muscle is found only in the heart. All right, so that's the only location that we find it. It characteristically, it's sort of a mix between number 1 and number 2. I'll explain. This is not voluntarily controlled, so we say it's involuntary. I'll write that word out in case I use that word on the quiz. It means the same thing. That's supposed to be an N, involuntary. So that's similar to smooth muscle in that case, but the cells are striated. So that makes it similar to skeletal muscle. They have a striped appearance. That has to do with the way they actually contract. The cells are striated, and the cells have 1 to 2 nuclei per cell. So that puts them sort of in the middle. They can have more than 1 nucleus, but not anything close to what skeletal muscle, number 1, has. Skeletal muscles have multiple nuclei in each cell. These cells have 1, sometimes 2 per cell. So they're sort of an in-between. All right, that takes care of the muscular tissue, which is nice and easy. The connective tissues, I'm going to tell you, they're the worst. So spend most of your time studying those connective tissues because they're the most complicated, as well as that's where we spent most of our information on these tissues. Now, for the last bit, I'm just going to get rid of these muscle tissue whiteboards. So let's do that. And I'm going to go do a quick whiteboard on nervous tissue. It's our last tissue of this section. It's the last type of tissue in the human body: epithelial, connective, muscle or muscular, and nervous. So nervous tissue, I'm going to give you some general characteristics. Location is the brain. Spinal cord and nerves. Sometimes we say peripheral nerves because nerves are the things, you know this, nerves are the things that extend out into our appendages away from the spinal cord. They carry information to and from the spinal cord. So that's the major location. Some general characteristics. This type of tissue is highly non-regenerative. So if this tissue type gets damaged, it doesn't regenerate hardly at all. It used to be thought that it doesn't regenerate at all, period. But there is a little bit of evidence that sometimes we can regenerate damaged nerve tissue. It depends on the degree of damage that is done as well as the location in the body. But in general, we say nervous tissue is non-regenerative. Muscular tissue, by the way, is partly regenerative, but epithelial is the most regenerative of all of the tissues that we've gone over so far. All right, so let's say a few more things about the nervous tissue. There's 2 cell types. Oops, that was a mistake, so let's erase that. And those are, first and foremost, neurons. And these are the cells that actually generate and conduct electrical impulses. And the second cell type, and it's a whole group of cells. I'm not going to list them all now because you'll learn them when we study the nervous system in detail. They're called neuroglia, G-L-I-A. These are considered support cells of the nervous system, and they do not conduct electrical impulses. So we're not going to spend a whole lot of time on nervous tissue now because we study that in great detail during the nervous system section of this course, which is the last section. It's super complicated. Hopefully you'll be up to speed even more with your A&P by then. As this course goes on, we just get into more and more detail. That's why you'll find all A&P books are basically organized the same way. They all start with introduction, then tissues, then integumentary system, and then almost all A&P books that I've ever opened are organized the same way. It just goes integumentary, skeletal, muscular, nervous, endocrine, yada, 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 on in the same order. And the reason for that is the complexity of these organ systems. They get even more and more complex. And so the thought is somebody learning this stuff will have the ability to understand the most complex material toward the end. All right, so before we completely leave tissues, I'm going to talk about tissue repair. And I'll go over the major parts of tissue repair, and then we'll be on to the integumentary system. So let me pull up a new whiteboard here. And I'm just going to write this header. And I'll highlight the major things. Just to remind you, these meetings, these online meetings, are not supposed to replace you reading the material. I'm highlighting the major things that I think are most important, but that doesn't mean that you should only show up to these meetings or watch these videos and then think that you're completely prepared for the quizzes, because you won't be. You need to read the material and then also watch these meetings or attend these meetings so that you know the most important topics and the detail of those and you understand the detail of those most complicated topics. So tissue repair, there's basically two methods that our tissues repair, and those have names. The first one is called regeneration. And this type of tissue repair refers to when we replace the original tissue with the same type of tissue. So we just replace the original with same type of tissue. That seems pretty straightforward, and it is. But that's different than the second type of tissue repair, which we call fibrosis. And in this type of tissue repair, there's fibrous connective tissue. You know what this is. You just didn't probably know the name of it. Fibrous connective tissue replaces the original tissue type, and it's what we call the formation of scar tissue. So fibrous connective tissue replaces original tissue, and then I'm going to, in quotes, we call that scar tissue. Now, some tissues are highly regenerative, and the regeneration process is what goes on most of the time. Other types of tissues, when they're damaged, are almost completely non-regenerative, and so they use this type of tissue repair when they get damaged. But to be honest with you, almost all tissues undergo some variation of both of these, and it depends on the tissue that was injured originally, and B, the degree of damage that was done. So you know that if you get a small cut, your epithelial tissue, your skin, is highly regenerative. It usually just replaces itself over time. And you also know that if you have serious damage, a serious laceration or a serious injury, sometimes some of that original tissue comes back as regeneration, but oftentimes fibrosis is the major type of repair, and you get a lot of scar tissue. So it depends on tissue type and the type of damage. So I'm going to go over what happens, the steps sort of to repair. And I'm just going to list them and say a few things about them. And they're just 3 steps. First, usually we get an inflammatory response. So I'm going to write inflammation. So when tissue is damaged, these are in order, by the way, after tissue gets damaged. The first thing that happens is we get inflammation. So the damage, what happens is the damage of the tissue causes chemicals to be released from that damaged tissue. And the chemicals are what cause inflammation. So I'm just going to write chemicals, like histamines, for example. Cause inflammation. And then we get in this stage something called, after the chemicals are released and we get inflammation, we also get something called hemostasis, which just refers to blood clotting. So these 2 things happen in the first stage of inflammation. All right, I'm just going to pull up a new whiteboard and leave this one here in case we need to come back to it. I'm going to write number 2. What happens next in tissue repair is organization. So the first step was inflammation. The second step is organization. Organization is really the beginning of the true repair process. And here's what happens. The blood clot that happened in the first stage is replaced by something called granular tissue. All right. Granular tissue is really a delicate pink tissue. You've seen that. It's when a scab, for example, a scab on your skin falls off, and there's that really light pink tissue underneath that scab. That's what we call granular tissue. It contains a whole new capillary bed, its own sort of blood supply. That's what gives the tissue that granular appearance. So this will be good for you to review this term. Fibroblasts, during this stage of tissue repair called organization, fibroblasts in the new tissue release growth factors. Don't worry about what growth factors are. They're just chemicals, hormone-like chemicals that help initiate growth. So I'm going to expect you to know what deciphering this word. So let's review this. What is a fibroblast? It's an immature cell that secretes fibers. And in this case, it also releases chemicals called growth factors. All right, let's go on to stage 3. This is where we get the final step of either regeneration, I'm going to put or fibrosis. And it depends, like I said at the beginning of this, it depends on the type of tissue that was damaged and the type of injury or the degree of injury that occurred. Sometimes we'll get almost all completely regeneration. Sometimes we'll get almost all completely fibrosis. Usually we get some sort of combination between the two. So during regeneration, basically the new tissue pushes the blood clot off, like the scab. I'm just going to say new tissue replaces blood clot. And this usually occurs also in tissues where we have a lot of active stem cells, like in the epithelial tissues. Fibrosis, I'm just going to remind you, this is just fibrous connective tissue that actually replaces the original tissue type. And you know what scar tissue is. It's that tough, hard, fibrous tissue that has a very low blood supply to it. All right. Now, the last thing before we completely leave tissue repair, I'm just going to give you a classification of, this is very quick, of different tissue types and their repair capabilities. So I'm going to classify these. I think your book does this too. The tissues in our body that are highly regenerative. So I'm going to write high regeneration. And I'm going to tell you which tissues. Now you know we've finished tissue types. So this epithelial is highly regenerative. Bone is also highly regenerative. It does take longer to repair when you break a bone, but depending on the severity of the break, it usually repairs itself quite well. Areolar is highly regenerative, that loose connective tissue. Dense, irregular, that stuff that we find deep in the skin. So bone, areolar, and dense irregular, just to remind you, are types of connective tissues. They're all considered highly regenerative. And blood, I'm going to put bone marrow. I'll write red marrow because it's full of stem cells. That's that tissue that forms blood cells. The next classification, I'm just going to write moderate, where we get less regeneration, but not completely unregenerative. So I'm just going to put moderate regeneration. List these tissue types. Sorry, it's pollen in the air. I can't speak very well. I get a lot of secretions in my throat. Smooth muscle is moderately regenerative if we get damage to it. Dense, regular connective tissue, which, just to remind you, that's tendons and ligaments in the body. Those have some regenerative capabilities. That should be W-E-A-K, not E-E. Weak regeneration. This means that it's very difficult for this tissue to regenerate, but it does in some cases. Cartilage has weak regenerative capabilities, and skeletal muscle, which is somewhat unusual. Most of the tissues that have high regenerative capabilities have a high blood supply, and believe it or not, skeletal muscle has a relatively high blood supply, but it has weak regenerative capabilities. And finally, what we consider no, so I'm just going to write none, no regeneration are tissues like cardiac muscle. So usually when our heart muscle gets damaged from you, and usually how that happens is from deoxygenation, if you get a blood clot. So a heart attack just means a clot in one of the arteries that supplies heart muscle. And if that happens, heart muscle dies quickly and it doesn't come back. So cardiac muscle and pretty much central nervous tissue, the brain and the spinal cord. Have very little to zero regenerative capabilities. All right, we're completely finished with tissues. I'm going to start us off on the integumentary system. And then my goal is to, I know that Monday is a holiday, and I get it. I'm going to hold another Zoom meeting either on Sunday or Monday, and it's totally optional. I'm mostly doing it to get it recorded. So I am going to do another Zoom meeting. I'll think about it today and put the invitation out. I'll talk while I'm erasing this and putting up a new board. Anyway, my goal is to get I'm going to start the integumentary system right now, and then I'm going to finish it for quiz 2, which will be posted on Tuesday. I'm going to finish the integumentary system sometime either Sunday or Monday so that you're well prepared for the quiz 2. But right now I'm going to, and I'll record that. So if you can't make that meeting, I get it. Don't worry. I will post the recording of it, and you can watch it whenever you have time. Let's get at least started on the integumentary system. This is really difficult. I get it. This is so fast. It's difficult for me. I can't imagine what it's like for a student to have to do a 15-week course in 5 weeks. So you do the math. We're going 3 times faster, and we're doing three times as much material per week as you do during a normal semester. But I am contracted to go through all this information, so I have to do this with you so that you're prepared for not only A&P2, but prepared for what it is you want to do after you leave college. When you, and I assume that's going to be something in the healthcare field, you're going to be expected to know this material. So let's go for this. Integumentary system. Everybody thinks of the skin, but it also includes hair, nails, and some glands of the skin of this system. Not all glands in the body are part of this, but like sweat glands and sebaceous glands. So there's the constituents that make up the integumentary system. Now the major functions are many. The list is long. I'll just list some of them. The biggest one is protection. But I'll list some of the other ones. Sorry, I was going to write insulates. So it helps with temperature control. It also cushions, which is really almost synonymous with protection, but it cushions, it secretes things. So I'm going to write secretion. It helps us, it helps our insides from drying out, and so it prevents desiccation. If you're outside in the hot sun, the vast majority of the interior of our bodies is made up of water, aqueous material, and so it prevents that stuff from drying out. Temperature regulation, and this one, our skin is responsible for synthesizing a vitamin, for creating, making. It synthesizes vitamin D. When we're out in the sun, our skin actually produces vitamin D. All right, so those are the major functions. The main, before we leave today, I'm going to talk about the major layers of the skin. I'm sure I won't get to hair and nails and all that business, or glands, but I do want to highlight the layers of the skin, okay? And there's 2 major layers, and then there are sub-layers within the major layers. So the 2 major layers are the epidermis, which is the most superficial, and the dermis, which is deep to the epidermis. And I'm going to go through these 2 major layers in a bit of detail right now before we leave, okay? So I'm going to call up a new whiteboard. And I'm just going to say epidermis, give you some general characteristics, and then go over the sublayers. First and foremost, this is avascular. That means there's no direct blood supply to our outermost, most superficial layer of the skin. So it is avascular. I'm going to list the cell types. There are others, but I'm just going to keep this list kind of short. There are things called keratinocytes. And these are cells that produce the protein keratin. Keratin is a very hard, tough protein that gives our skin cells their toughness and their physical hard and toughness to them. Melanocytes are cells that produce the pigment melanin. That's what gives our skin its color. Produce pigment called melanin. We all have melanocytes. I'm from Northern European descent. My parents were both from Scotland, so I have pale skin, and which is bad when I go out into the sun. And so I have melanocytes, but they're not very active. They don't produce a lot of melanin. Somebody who has darker skin or olive shade skin from the Mediterranean or Africa or wherever, or the South America, the Caribbean, they have more melanin in their skin, which is much more protective against UV rays. I'll talk about that later, skin cancer and all of that. Dendritic cells. Speaking of skin cancer, my father actually died from malignant melanoma, so I'm very aware of that. Don't worry a lot about, I'll talk, or you'll learn, we don't do this in AMP1, but in AMP2 you do the immune system, and these are actually immune cells that are found in the skin. They do something called, they present antigen to our T cells and B cells. If you just know that they are immune cells, that's good enough for now. And finally, we have tactile, or they're also known as Merkel cells, M-E-R-K-E-L. These are sensory types of cells. They're like nerve endings. So I'm just going to write. So when you feel touch and things like that in your skin, they're nerve endings that sense touch. All right, there's just a small list of some of the cells that we find in our epidermis. Now I'm going to go through the 5 major layers of the epidermis. So I'm going to write 5 sub-layers and then call up a new whiteboard, okay? I'll describe to you where these layers are located. So remember, we're talking about the epidermis. That's the most superficial, the outer layer of our skin. So let's go to a new whiteboard. And we're going to do those 5 sublayers right now. The first sublayer of the epidermis is called the stratum, S-T-R-A-T-U-M, stratum basal, and that's just comes from the word meaning base layer. So this is the deepest layer of the epidermis, not of the skin as a whole, only of the epidermis. I'll draw a picture of this after we list these layers, okay? The cell types, there are 2 specific cells that we find in this deep layer. Melanocytes, we already know what they do. They secrete melanin that gives our skin its pigment, protects our skin from UV rays. So we have melanocytes and basal stem cells. And those basal stem cells produce new skin cells all the time. So that melanocytes secrete the pigment melanin, which protects our skin from UV rays. Basal stem cells make new skin cells constantly, all the time. I'm just going to write that so you don't forget. To protect from UV light damage. That's the stratum basal. Now I'm going to go to the next layer. I'll draw a nice picture of all of these layers as soon as I list them all in word form. The next layer is called the stratum spinosum. It gets its name because how the cells look. They're spiky or spiny shaped. That's where it gets its name. I'm not going to test you on that per se. So there is still, this will make sense after I draw my picture at the end. There is still mitosis going on. That means cellular division or new cells being made in this layer. Cells are still alive. In this layer, they're still living. And they're still receiving nutrition from the dermis. So, but there's no new cell types to learn in this layer per se. Now I'm going to go to the third layer, and then because there's 5 total, I'll most likely call up a new whiteboard. The next layer is called the stratum. Oh, by the way, the stratum spinosum. This is very thin. Sorry, it's basically 1 cell layer thick. That'll make sense when I draw my picture. This is it's much thicker, many cell layers thick. The stratum granulosum is the third layer, and it's also thin, like layer number 1. And this is sort of a special layer that has it gets its name granulosum because there are granules found in the cells. If we look in the cytoplasm of the cells in this layer, they have granules in them. So I'm just going to write 2 types of granules. You'll see the significance when I tell you what they are and what they do. The first are called lamellar granules. So granulosum gets its name because of the presence of these granules in the cells. And the first type are called, that's LAM as in Mary, ELLAR, lamellar granules. These are special things. They give our skin its waterproofing ability. So I'm just going to write H2O proof. The reason that we can jump into a swimming pool or go into the ocean and water doesn't get through our skin is because of the presence of these granules in this layer. Second type are called keratohyalin granules. It's a long word. It's supposed to be an N. And what these things do is they help form keratin fibrils. So giving our skin its toughness as well. All right, I'm going to need to go to a new board in order to do the last 2 layers of the epidermis. So let's click. I'm saving these boards during these layers, by the way. So if we need to go back to one at the end, you can just ask me and I'll flip back to these boards. I don't mind. Oh, that's giving us, sorry, that's giving us all 3. Looks like I may, there's a new board. So let's do layer 4. Stratum lucidum. That's LUCIDUM. Okay, so in the stratum granulosum, what granules mean is this on the previous board. Let's just go back there really quickly. But this layer has granules in the cell. So if this is a cell that's in this layer, there are these hard granules in the cytoplasm. Let's just say here's the nucleus of the cell. These granules, certain types of them, let's color these blue, they waterproof our skin. And then there's other granule types in the cells that help give our skin its toughness. So there's just these hard things, these functional organelles that both waterproof our skin in the case of these, and also form keratin fibrils that gives our skin its toughness, which are these types of granules. Let's go back to stratum lucidum. This is super thin. Let me get my black pen back. I'm just gonna write super thin, clear layer. The only thing I want you to know about this is we only find this layer isn't found everywhere on the body. We only find this layer in what is called in thick skin, and that is found on the palms of the hands and the soles of the feet. So this stratum lucidum is a thin layer that we only find on the palms of the hands and the soles of the feet. There's not much to the functionality of this layer. When we look at skin under the microscope, we can see it if we're looking at skin specifically from the palms and soles. I think it helps bring showing these humps in the dermis and the papillary dermis up to the surface of the skin. That's why we have, quote, fingerprints and prints from the soles of our feet. But you don't have to know that. I just want you to know what this layer is and that it's only found here, okay? The last sublayer of the epidermis is called the stratum corneum, C-O-R-N-E-U-M. This is the uppermost, the outside of the skin, the surface of the skin. I'm going to write uppermost superficial layer. It's very thick. So I'm going to write the word thick. This is actually something like 30 to 40 cell layers thick. It depends on where on the body you're talking about, but in general, anywhere from 25 to 40 cell layers thick. The cells are all dead in this layer. It's continually sloughing off of our bodies every day. That's supposed to be an H. It's continually sloughing off and being replaced. I'm going to now draw a picture of these layers along with the two layers of the dermis and then call it a day. You don't have to draw this. I'm recording this. You can watch it several times. There's pictures in your textbook of these layers. But while we're talking about these layers of the skin, I think it is appropriate to draw them for you just to give you some sort of reference or context, okay? So let's do that before we leave, and then I'll call it a day. If we look at the skin under low power microscopy, that means not super magnified, what we'll find is something that looks kind of like this. On the very upper layers of the skin, it kind of looks like that. That's going to be the surface of the skin. And then below that, we see this wavy line like this. And then deep to that, we see this sort of connective tissue like this. And then deep to that, these are not the 5 layers of the epidermis. I'm just drawing you the whole skin. Then deep to that, we see this dense, irregular connective tissue, and it's super thick. So the reason I'm doing this is to give you some sort of frame of reference. Now, believe it or not, all 5 layers of the epidermis are located right here between the blue wavy line and the surface. So all 5 layers that we just went over of the epidermis are what you and I would consider at the top of our skin. Okay, so all 5 layers, stratum basale, stratum spinosum, stratum granulosum, and stratum lucidum and corneum are all located from this blue line up to the surface. So all we've done so far is we've named the 5 layers that are found right up here. These are actually 2 layers of the dermis. So the 2 layers of the dermis are many times thicker than all 5 layers of the epidermis. So that's the first thing to keep in mind. Is now I'm going to go through those. What I'm going to do is magnify this section right here and draw those 5 layers for you. Just keep in mind that even though there are 5 layers here, relative to the whole skin, those 5 layers are kind of thin. They don't make up a real thickness to our skin. So last whiteboard of the day, and then I'm going to quit. We're just going to do the 5 layers, those upper layers of the epidermis. So I'm going to go through just how I drew my original picture on the last board, as well as the 5 layers that I went through. I'll use the same color again. If this is that wavy line right down here, that blue line that I just drew, represents this same blue line right here. I'm just magnifying it, making it bigger so that you can see all 5 layers now. So let's go back here. Layer number 1 of the epidermis is located at the base of the epidermis. So the stratum basale, which is really very thin, is located down here at this wavy line. And the cells, like the melanocytes, for example, are located all along this line. So let's just say these dark cells are melanocytes because they secrete melanin. That's a dark pigment that protects our skin. And then the stem cells, the basal stem cells in that layer, they're not quite as dark. They're also located in this layer, intermingled amongst the melanocytes, like this. The melanocytes secrete this dark pigment, especially when the sun shines on them. So when they get UV light hitting them, they secrete this pigment-like material that helps, it sort of infiltrates this area and puts a coating over these. It helps protect the melanocytes themselves as well as these stem cells. And that's when you go out into the sun, especially pale skinned people like me, we get burned from damage, but we also start to secrete a little bit more melanin that makes our skins darker. People who have darker skin already have that protection already in place, which is great because Not that people with darker skin don't get skin cancer, they do, but they get a lot less UV damage when they go out into the sun. The stem cells, here's what they do. They just constantly make new cells. So I'm going to draw a stem cell over here so it's not messy. What this stem cell is doing is just constantly making new cells. All right? Baby cells. And as this stem cell, it's just a cell manufacturing plant. As it cranks out new cells, the older cells, they just keep rising to the surface through the layers, those layers of the epidermis. As they rise to the surface, they die. They cease to have living capabilities to them. So in general, this basal stem cell makes new cells, that's its job. And this cell, which is now in the stratum spinosum, it's still a living cell at this point. It's several cell layers thick. So these are all new living cells that those stem cells have produced, okay? So now we're in the stratum spinosum, cells are still alive. Then we get to the next layer called the stratum granulosum, which is thin. We're going up toward the surface. And remember, that has those granules in the cells. I'm going to make it very thin. And those granules give our skin its waterproofing ability and also start secreting those keratin fibrils that give our skin its toughness. When we get to this level, the stratum granulosum, the cells now are dead. They're no longer alive. They have the granules in them, but they're not truly living cells at this point, okay? As we go up into the stratum lucidum, which is only found on the palms and the soles, I'll give that a new color. This is actually should be number 4. Stratum lucidum. And it's really super thin and clear. There are dead clear cells here only in the palms of the hands and the soles of the feet. And finally, the last layer, I'll use black again. Number 5 is the stratum corneum. It's super thick. I won't draw all the layers because it would take too long. Stratum corneum is 25 to 40 cell layers thick. As these cells, they're dead, as we go up to the very surface of the skin, they get super flat. They're actually stratified squamous epithelial cells. And you know from our tissue lecture, from epithelial tissue lecture, stratified squamous epithelial is always found, usually it's for protection. So here's a stem cell way over here. That's where I am. It makes new cells that are alive. Those get pushed up constantly, those cells to the surface. As they get pushed up, they die and they increase their keratin content. Keratin is a really tough protein that gives these upper layers a real toughness to them. We also have keratin forming in our hair cells. You've heard of that before. So that's sort of how the epidermis works. Layer 1 is not the top layer, it's the deepest layer of the epidermis. And then as we go up toward the top of our skin, we have stratum basale, stratum spinosum, stratum granulosum, stratum lucidum, and stratum corneum. So that's sort of how it all works. I'm going to cut this meeting, this lecture here, because you've had enough, I'm sure. I have recorded this. I'm going to post it probably tonight, so it should be available. If you were not able to record, it should be available. I'm just going to stop the recording because this doesn't need to be So I just